Hey guys, today we are going to talk about a few different things, and we're going to start with how to solve a problem like 2C and 5C that were in your homework on Friday. So, for A and B, you're just actually finding the equation and what the numbers in the equation mean, and then plugging in a number for X, which is going to be the amount of time that has passed, and solving it that way. For C, you're predicting when, at what time the population is going to reach a certain number. So in that case, if you have your original equation, y equals 720,500 times 1.022 to the x, then whenever it says a million, then that's not going to be our time. That's going to actually be our y amount, because the y is the new population that we're finding. So it would be 1 million equals 720,500 times 1.022 raised to the variable x, and you're trying to actually solve for x. So the way that I want to show you guys to do that, because as of right now, you wouldn't be able to solve that by hand. We're going to learn a method that you would be able to do that by hand later this week. But for now, I want to show you how to do it on the graph. So I just put both of the equations in Desmos, and kind of similar to whenever you were solving absolute value equations, kind of what you're going to want to do is have y equals the left-hand side of your equation and y equals the right-hand side of your equation typed into two separate equations on Desmos. So that's what I've done here, and if you look at the graph, you can tell that you can't really see anything. So what you need to do is go on the graph and just start zooming out until you can figure out what's going on. And on this one, you kind of have to zoom for a while because we're going all the way up to 1 million. So there I can finally see that line. So I'm going to zoom in a little bit more and try to focus on right there where that intersection is. So I'm going to put that in the middle of my screen and then start zooming in. And then even though the graph of the 720,500 is really close to the y-axis, you should still be able to click on where that intersection is between the two. And you can see that that intersection happens at 15.064 and 1 million. So whenever you go back to your problem, remember you were solving for x, so x would equal 15.064. So let's come back here, and now we have x equals 15.064. But then you have to look at what that means in the context. So it's saying when will the population reach that? Well, it's 15.064 years, but then you need to know when that is. And so you're using the fact that that's the number of years since 1980. So that means 15 years have passed since 1980. So the actual year would be 1980 plus 15, or 15.064. But either way, then it would happen during the year 1995. So that would be your answer. You're not always going to have a year to add it to and stuff like that. But the way that you would find the answer to those is by typing each equation into, or each side of the equation into two separate equations in Desmos, and then finding the intersection. Okay, so next we have just multiple formulas that we need to go through. So the first formula is the half-life formula. So there are some things out there in the world like bacteria and different elements on the periodic table and stuff like that that have a half-life. And that means that this object or whatever it is, it's diminishing at a certain rate, so that after a certain amount of time, called the half-life, there's only going to be half of the substance left. So this is the formula for that. And so it's the initial amount of whatever you have times 1/2, and then it's going to be raised to the exponent of the time that has passed divided by how long the half-life is. So I would definitely make sure you write this formula down, and then we're going to go ahead and use it to actually solve a problem. So it says SR85 is used in bone scans. So first off, I know that there's an 85 right there, but that's not a number that we're going to be using in solving this. That's just the name of the element. So SR85 is used in bone scans. It has a half-life of 64.9 days. So that is H. And then it's write the exponential decay function for an 8 milligram sample. So that's the number of grams or number of whatever. That's the amount that is present initially. So that is A. And then you want to know, find the amount remaining after 100 days. So that's going to be T. So then if you're just plugging these numbers into the half-life formula, then you'd have Y equals, you need A first, which is the initial amount, and that is 8 times 1/2 raised to T is the amount of time that's passed, so that's 100 divided by H, which is the half-life of 64.9. And then you're going to need to type all of that into a calculator. Okay, so I've pulled up my calculator here, and whoops, I got rid of my calculator. I've pulled up my calculator here, and then I'm going to type in this equation. And I want to type it in just on the regular home screen whenever you first turn the calculator on. Even though we have Y equals, we don't have to type that in, or we don't have to go to the Y equals key or anything like that. You only go to the Y equals key if you're actually graphing it. So we're just going to type it in on the home screen. So I'm going to start with 8, and then I need to put in parentheses 1/2. I believe if you want to put a fraction in, you can hit alpha Y equals, and then that little n/d that stands for numerator over denominator, and just click on that button, and you can do 1/2, and then close my little parentheses, and then to get the exponent, you have to hit this little caret right here that's above the division symbol, and then I'm going to do alpha Y equals again to get my next fraction, and the numerator is 100, and the denominator is 64.9. And then you're just going to hit enter, and it's going to give you the amount left after 100 days, which is 2.75 pretty much. So I'm going to come back over here, and the amount remaining is going to be 2.75, and this was in milligrams, so I'm going to write milligrams behind it. Oh, wrong button. So then there are some special cases where you can alter that half-life formula and use it to talk about exponential growth as well. So that's only going to happen whenever you are told something is doubling, tripling, quadrupling, multiplying by 5 every certain number or certain amount of time. So in that case, instead of putting a 1/2 in the parentheses, you would just put a 2, or if it was tripling, you would put a 3, and that is supposed to say how long it takes to triple, and so on. So if it was quadrupling, then inside the parentheses, you would put a 4, and then the formula is A for the initial amount that you have times 2, or if it's tripling times 3, or if it's quadrupling times 4. And then the exponent is going to be the amount of time that has passed divided by how long it takes to double or triple or do whatever it's doing. So then I just did an example down here. So you have the population of mice in a field is quadrupling every 42 days. So since it's quadrupling, that means that in the parentheses you're going to need a 4, and it's happening every 42 days. And then there are currently 119 mice in the field. How many will there be after 16 days? So let's put that into the equation. So we would have Y equals the number of mice, or the initial amount that there are currently in the field is 119, times it's quadrupling, so we put a 4 in here, raised to the T, which is the amount of time that has passed, which is 16 days, divided by the amount of time it takes to quadruple, which is going to be 42 days. And then I would need to type all of that into my calculator. So I would start with 119, and then in the parentheses I would put a 4 raised to the power of 16 divided by 42. And after those 16 days, there would be 201.79 mice in the field. If you want to, since it's mice and you're not going to get 0.79 of a mouse, you can go ahead and round up to 202 mice. So then another couple of formulas that you're going to need to know, these are going to be super duper important, so you're going to want to write them down, is the compound interest formula and the formula for something being compounded continually, or usually instead of saying the word continually, it uses the word continuously, but you'll know what that means whenever you see it. But you're going to want to write both of these down. So both of them is going to be A, which is like the amount that you have. This is usually talking about like money in an account. So A is going to be the amount that you have after a certain amount of time. P is principal, so that's like the initial amount that you're depositing in the account. R is your interest rate that you get. Remember, with R, you have to change whatever percent it gives you to a decimal. T is the amount of time that has passed in years. And then N is the number of times that something is compounded per year. And so we're going to talk about that on the next page. But right now, make sure that you write both of these down. Oh, and while we're on it, the second one for compounded continuously, this is called the PERT formula. That E right there, notice I don't have it written down here anywhere. That's because E is actually going to be a number. So for E on a calculator, you're going to hit the second button and then the divide button. And then that'll give you E. So let me just show you real quick that E is a number. So you're going to hit second divide, and you see that little E that's right above the division symbol. If you hit enter, then E is just 2.72 or close to 2.72. So whenever you are using the PERT formula, make sure that you know that E is just a number. So it's about 2.72. And so then let's go on to how many times something is being compounded per year. So for each of these, I'm just writing the number of times that it's compounded per year. And so that's going to be what you're plugging in for N in these formulas. So if it's compounded N times per year, then for monthly, N is 12, quarterly, N is 4, annually, N is just 1, and then semi-annually means twice every year, so you would put a 2 in for N. Some other ones that you may get, you could get daily, you would do 365. I wouldn't imagine you would get weekly, but if you got weekly, you would put 52, but you wouldn't normally get that because there's not exactly 52 weeks in a year. But that is what you would plug in for N based on the situation. So then I want to go through an example. So this says Ruth invests $10,000 in an account that earns 2.85% compounded quarterly. How much will she have after 30 years? So our formula for this is going to be A equals P times 1 plus R divided by N raised to the N times T. So A is the amount that we're looking for. That's the amount that she's going to have after 30 years. So we're just going to write A equals. P is the amount that is initially invested. So 10,000 times 1 plus R, so 2.85%. You have to change that to a decimal. So it's going to be 0.0285 divided by N. So the number of times compounded per year, it says quarterly, so you're going to put a 4 raised to the N again times T, which is after 30 years. So this is what you would type into the calculator. So going to my calculator, you would start with the 10,000 times 1 plus, and then I'm going to use my little alpha y equals again. Alpha y equals, and get, oh, okay, it went to y equals. Okay, let me scroll back over to get to where we were. Okay, and it was alpha. It's like not noticing I'm hitting the alpha button. Okay, alpha y equals. Okay, give me 1 second because my calculator is messing up. Okay, I got my fraction to come up. So then I had on top 0.0285, and then it was divided by 4. And then close your parentheses. And on the outside, it was raised to the 4 times 30th power. And you get $23,442.57 if you round it. So it was $23,442 and how many cents? 57 cents would be your answer on that one. Okay, I know this is getting long, so bear with me for just 3 more examples. So on my next one, it has you deposit $1,600 in a bank account, find the balance after 3 years for each of the following situations. So we're going to have A equals the initial amount, which it tells us is $1,600, times 1 plus the rate. So the rate of 2.5 in decimal form is going to be 0.025. So 0.025. And then divided by n, it says compounded monthly, so n is going to be 12. Raised to the 12 times after 3 years, so 12 times 3. So then we're going to type that equation into our calculator. So we have 1,600 times 1 plus, and then alpha y equals, to get my little numerator over denominator thing, and it was 0.025 compounded monthly, so divided by 12, and then that is going to be raised to the 12 times 3 power for 3 years. And you would get $1,724.48. So 1724.48. So that would be if it was compounded monthly. So then you want to do another one where it's compounded at 4% yearly. So you're going to have A equals 1,600, because that was our initial amount still, times 1 plus our new decimal for percent is going to be 0.04, because 4% would be 0.04 as a decimal, divided by, if it's compounded yearly, then it's only compounded 1 time per year, raised to the 1 times the 3 power, because the time is 3 years. So then you're going to type that into the calculator. So you would have 1,600 again times 1 plus, and then get your fraction in there. And the numerator was 0.04 for 4%. The denominator was just a 1 because it was only compounded 1 time per year. And then raised to the 1 times 3 power. And that gets you $1,799.78. So that gives you an example of how it works if it's compounded monthly, yearly, and then on the last slide, we did quarterly. And so our last example is one where it is compounded continuously. So this is where you have to use that PERT formula. So always remember, continuously goes with PERT. Always leads to PERT. So in this one, you invested $1,600 again and at a rate of 6.9%, and it's compounded continuously. And you want to know how much is there after 10 years. So you're going to do A equals P is the initial amount that you put in the account. So 1,600 times E, which remember, E is just a number. It's second divide on your calculator. And then raised to the rate, which is 6.9%. So you would move the decimal place and it would be 0.069. So 0.069 times T, which is the time that's passed. So it would be 10 years. So then we're going to type that into the calculator. And you have 1,600 times E, which is second divide, and then raised to the rate, which is 0.069 times the time that's passed, which was 10 years. And that $1,600 becomes $3,189.94. And it was $3,189.94. And that is how compounded continuously is going to work. So I know that's a lot of formulas all at one time. I tried to do an example of each one. Just make sure that you write all of the formulas down. Normally in class, face-to-face, you would have to memorize all of those. So be thankful that you can just write them down this year. And we're going to try our best to get through each of these formulas and do some problems where you're using each of them. So let me know if you have any questions, and otherwise, I hope you have a wonderful Monday.